All right, trapezoidal. You've already done LRAM, you've done MRAM, you've done RRAM, and this is the last type of approximation that we're going to do. It's called trapezoidal, and pretty much, just like the name implies, you add up area of trapezoids. In case you don't remember how a normal trapezoid looks like, when you were in geometry, here's how it looks. You got to remember that? Where this is called the base, they usually call that B1. This is called another base, B2. And then the height is perpendicular to the base, and that's called the height. And then they give you the equation of trapezoid. You can do rectangle, triangle, triangle, but don't do that, guys. That's where this is derived from. Base 1 plus base 2 times height divided by 2. That's how you find area of any trapezoid. Cool or not cool? The trapezoids that we're going to work with are going to look like this. Trav, this changes our formulas. No, the properties still apply. Base 1 and base 2 are still parallel. So this is base 1, this is base 2, this is still your height. Bless you, bless you, bless you. It's still perpendicular to the base 2 here. So the area formula is still the same. Times height divided by 2. Cool or not cool? Nothing crazy, right? All right. How will our trapezoids look? Guys, I'm only going to derive this one time because most of the time we won't even have a perfect delta x. Let me show you how our trapezoids look. So we have a scale, x, y, and I have a curve. I'm just going to make something up. Let's see. I'm going to go, that's fine. And I have a point, and I got another point, and here's how our trapezoids look. Do you guys see that trapezoid? It's like where this is your h. So your h is your delta x, really. Do you guys see that? And then we have another trapezoid here. And then we got another trapezoid. And then another trapezoid. See? And I guess since we're already talking about this, we'll go ahead and derive this formula. y0, y1, y2, y3, y4. What is this y? The vertical length. That makes sense or no? So how do I find the area of these trapezoids? There's 4 trapezoids. Notice. I would say, well, y0 plus y1, that's base 1 plus base 2, times height divided by 2, plus here's my second trapezoid, y1 plus y2 times height divided by 2. That's a 0, 1, 2. That's a 3. Here, let me. Y0, y1. That's a y. Y2, y3, y4. Plus, here's my third trapezoid. Y2 plus y3 times height divided by 2 plus y3 plus y4 times height divided by 2. I think that's all I have. Yep, that's all I have. I just have those 4 trapezoids. Cool or not cool? What does all 4 of these trapezoids have in common? A what over what? So I can factor out that h over 2. And look what you have. y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4. How many y1s do you see? 2. How many y2s do you see? How many y3s? So, for this particular equation or function that I wrote, h over 2, y naught plus 2y1 plus 2y2 plus 2y3 plus y4. I want you to notice that the first y value does not have a 2 in the front, or a coefficient of 2, and the last one does not have a coefficient of 2 in the front. Do you guys notice that, guys? Mm-hmm. Okay, so look at this formula here. To approximate the area from a to b of f of x dx, use, and this if you're doing trapezoid, h over 2. Look at that. There's no 2 in front of that. 2, 2, 2, dot, 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 just continue. Second to the last, there's a 2, and then the last point, there's no 2. That makes sense? Notice I have 4 trapezoids, but I need 5 values. 1, 2, 3, 4, 5. Cool or not cool? And then this is just saying that that these two are equivalent. And you can prove that with geometry. It's the same. LRAM plus RRAM divided by 2 will get us that, but it's not a big deal. How do we feel? Nothing crazy, right? All right, so after today, you'll be able to do really pretty much everything now, except for doing antiderivatives, but we'll talk about that hopefully Friday maybe, because tomorrow I want you guys to practice. All right, use the trapezoidal rule. We're going to go slow. With n equals 4 to estimate 1 or 2 of x squared dx. Compare the estimate with the exact value. We don't know how to do antiderivatives yet. I mean, we do, but we don't. Okay, we'll just do it with a calculator. All right, here we go. Exaggerate x squared, the quadrant 1. So I'm doing quadrant 1, and I'm going to exaggerate x squared. I'm going to say this is 2, and I'm going to say this is 1. How many trapezoids do they want? 4. So let's see. Boop, boop, boop. Here's my first trapezoid. I'm going to use burnt orange. Here's my second trapezoid. Third. And fourth. I didn't do a good job of drawing. If you have an increasing curve like this, yeah, here I am zooming in. If you have an increasing curve, a strictly increasing curve like x squared, will my trapezoid be an overestimate or an underestimate? Over, just barely. So I didn't do a good job. So here it is. I'm going to put the word zoomed in. Zoomed in. Just barely, but it is an overestimate. Do we see that? Okay. Let's find the area of this trapezoid. We can use the formula if you want. The height, I guess this is my height. So I'm going to write delta x is equal to my height, which equals 2 minus 1 divided by 4. Does everyone know where I'm getting that? And that's going to be 1/4. 1 to 1.5. Yep. Cool or not cool? All right. Here we go, guys. This is my first. This is my first y value. Remember, it's x squared. So where do I start? What's the x value that determines the y value? 1. So I'm going to write. So I'm doing this. I'm doing h over 2, unless you don't want me to, and I can do each rectangle, each trapezoid by itself. Doesn't matter. What do you guys want? Formula or no formula? Formula? Okay. So I'm going to go 1/4 divided by 2, open parenthesis, and my first y value is 1 squared, plus my next y value is 1.25, and what do I do with that? Square it, because it's y equals x squared. Plus, oh, I'm forgetting something. What am I forgetting right in front of that? A 2, because that's part of the formula. And we derive the formula right here, guys. Plus 2 times, what's the next y value? 1.5 squared, plus 2 times 1.75 squared, plus, do I need a 2 in the front or no? Nope. What did I put? 2 squared. Close the parenthesis. So now you need a calculator. So let me take out my calculator. Yeah, those are, the function is y equals x squared. Those are the x values. So how do we determine the y? I got to square it. 1 squared is 1. So my y value at this point is 1. You know what I mean? Okay. Good question, miss. Good question. Yeah, don't ever hesitate to ask me questions, guys. Ask me questions if we have points of confusion. Yeah, if you have your calculator, take out your calculator so you can practice. If you don't have one of these, ask me for one, So I can give you one. Well, loan you one because you want to get used to how to use it, guys. Yep. Okay.
Thanks, Alex. We have 2.34375.
All right. 1 squared plus 1 squared plus 2 times 1 point.
I got 2.34375.
Times 1/8, right? Because it was 1/4 divided by 2. $2.34375. Yeah, don't be a robot, miss. I need you to understand where all the little intricacies are coming. I'm not a Delta Math hater. It's just that sometimes Delta Math does it robotic.
Like I was saying, it's just like the way I write it makes more sense than that.
34375. 3, 4. Well, that's just 1/8. And you don't have to do that. You can just do. You guys told me to do it. I could have just done trapezoid at a time.
I mean, like the way I do it.
Oh, you did LRAM plus RRAM divided by 2. Okay. Core. Oh, we didn't even find the exact. That's the what? This is an overestimate. All right. Here's how you do it real quick with your calculator. Push math. Go down to number 9. And here's your little symbol, see? From 1 all the way to 2 of what function? X squared. I didn't type it into Y1, so that's why I'm typing it like this. And there it is. And no surprise, this is the exact 2.33333. Are we shocked that we got a number bigger? No, because you guys told me that it was an overestimate. Not by much, but it is an overestimate. Do you guys see what's going on? Okay. Yeah, we're gonna do a.
I feel like I'm listening to one.
We're gonna do a free response question today from the AP, and they want to see trapezoidal, like they don't. Yeah. Here we go, guys. Example 2, and we're gonna go slow. On the interval -2 to 4, if 3 equal subdivisions are used, so that means they all have the same delta x. That's what that means. So same delta x, which means that's going to be my height for this trapezoid because it's standing up. If you call it that, if you want to call the trapezoid standing up. What is the trapezoidal approximation of this? So before we even start, do you know how this function looks like? Be honest, without a calculator. Okay, this function is the same thing as saying 1/2 of e to the x. So it's just a vertical compression of e to the x. So here I go. I'm going to exaggerate. Here's my scale. And instead of touching the y-axis at 1, it's going to touch it at 1/2. And it looks like this. Cool or not cool? Yeah, log is the one that, this is exponential. Yes, in Algebra 2, exponentials and logs. Both.
We learned all of them. No, but it didn't stay. Because we learned it with like quadratic.
All right. Do you know how this looks like?
Like that, but
yeah, like that, but like this. And it crosses at 0, 1. Do you know how this one looks like?
Like that, but backwards.
That. We also talked about it in this class.
I don't talk about it. It's just like I feel like they can solve it like. Yeah, I need to.
Ln of x. Ln of x crosses at 1, 0. All logarithms cross at 1, 0. Ln of x is specifically the inverse of e to the x. And log, so if I were to tell you y equals 2 to the x, that looks like this one. And what's the reciprocal or the inverse of this guy? Y equals log base 2 of x. Okay, so we're good. All right, let's go back to the problem. Let me erase some of this. Any questions so far, guys? All right, here we go. Ready? Focus, guys, focus again. All right, here we go. How many rectangles do I have between -2 and 4? So here's -2, and I'm going to say here's 4. And let me see. 1, 2, 3. So I have nice big, did I say rectangles? Trapezoids. Trapezoids. Here's my first trapezoid. No, this one. And I need this point. So here's my first trapezoid. Here's my second trapezoid. And here's my third trapezoid. Are we still okay? Nothing crazy, right? All right, Gadetto. Here's what I want you to do. Ready? You can do it a trapezoid at a time, or you can use your formula. On this one, because it's fine to use our formula, but make sure that you don't become a robot. Are we okay? Or do you want to do it a trapezoid at a time? Trapezoid at a time so we can get experience? Okay, perfect. I love it. I love your frame of thought. All right, here we go. Ready? So the height of each trapezoid is, it looks like it's what? 2. So I'm going to write 2 times base 1. Now this base, you know what? Okay, that's fine. Base 1 is the y value, this specific y value. How do I get that y value? Plugging in a -2 in there. So e to the -2 over 2 plus, that's base 1. I need the other base. That one is at 0. E to the 0 over 2. Close it. Okay, I'll wait. Base 1, base 2 times height, and all this is divided by 2. So I'm going to put it like that. Plus, are we still okay? All right, 2 times base 1, which is e to the 0. Look, here, I'm labeling my trapezoids. Trapezoid 1, trapezoid 2, trapezoid 3. This was trapezoid 1. Here's trapezoid 2. Plus, what's the next base? E to the 2. Oh, and I didn't put over 2. Come on, guys, tell me. And I have to divide this by 2. Base 1 plus base 2 times height divided by 2. Plus, here's my third trapezoid. Here's trapezoid 2. Third trapezoid. 2 times base 1, e to the 2 over 2 plus e to the what power? 4 over 2. And all this divided by 2. Are we still okay? All right, here's what I noticed. 2 over 2 is a 1. 2 over 2 is a 1. 2 over 2 is a 1. Yes or no? What do all of these have in common? Or what can I factor out? No, because not, look, a 1/2. Do you see how all of them have a 1/2? So that's what I'm going to factor out, guys. So here it is. I'm going to write it up here. 1/2, open parenthesis, and I'm going to have e to the -2 plus e to the 0 plus e to the 0 plus e squared plus e squared plus e to the 4th. Close it. How do you feel? Nothing crazy, right? All right, I'm going to reduce it. 1/2 e to the -2. How many e to the 0s do you have? 2 e to the 0. Sometimes they would simplify that. Sometimes they don't. I see that they didn't. How many e squares do I have? 2. And then how many e to the 4s do I have? Oh, look, we would have gotten the same answer with our formula, but I'm glad we did it this way so you guys can see where it's derived from. So now we start looking for that answer, and I see it. What's the answer choice? D. Yep. Cool or not cool? Yeah, they tried to trick you with the changing the order. All right, here we go. This one, I think this one's similar to UH, where they give you different. All right, let's read it. The function f is continuous on the closed interval 1 to 7 and has values that are given in the table. 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, using the subintervals, what is the trapezoid approximation of that? The last two, I know I definitely took them from Delta. Are we okay so far? I want you to notice, they want me to do 3 trapezoids, those 3. So now the heights of each trapezoid is not the same, so I can't use my formula anymore. I'm just going to have to do it one at a time. Cool or not cool? All right. This the delta x is your height, and this are your bases. Base and base. So for the first trapezoid, I'm using, do you guys want me to color code it? Here's my first trapezoid in red. Here's my second trapezoid in sky blue. And here's my third trapezoid in purple. Do you guys see that? Okay, so I'm gonna color it. So here it is. Ready? Base 1, 10, plus base 2 of the first trapezoid, 30. And I'm going to multiply that sucker by 3. And all this is divided by 2. That's your first trapezoid. Yay or nay? Yay. Here comes my second trapezoid. I'm changing my colors. Base 1. It's the y value because it's the height. It's 30 plus, what's base 2? 40. And then times the height. What's the difference between 4 and 6? 2. And I'm dividing this by 2. And let me change my color now. Plus. Now I'm doing it in purple or light purple. Base 1, 40 plus base 2 is 20. What's my height? 1. And I'm dividing by 2. More than likely, it'll be a calculator problem, but just in case, if the numbers are nice enough, it'll be a non-calculator question. So let's see. 30 plus 10 is 40. 40 divided by 2 is 20. 20 times 3 is 60. Do you guys see how I did that? All right. Let's see if I can do this one here. 40 plus 30. Nope. Okay, I'll just cancel out the 2's then. 4, 5, 6, 7. 70. Do you see how we did that? All right, let's see if we can do this one. 40 plus 20 is 60. 60 times 1 is 60. 60 divided by 2 is 30. Okay, we can do that without much work here. 70 plus 30 is 100, so 1 what? So 160. I always think there's a step here, and I've been doing this a lot. Sorry. Yeah, I probably should. Cool or not cool? Okay, let's keep going, guys. Oh, this is just like a quick overview. Yay! And I know you guys are visual, so I'm going to draw some pictures for you guys. So look, quick review. If a function f of s is strictly increasing, so you don't even need to put a y-axis, just an x-axis. Here's A, here's B, and you don't care about, you know what, we'll do concave up and concave down, just so you guys can verify. Here's concave up, increasing, and here's concave down. LRAM with equal subdivisions. Okay, we'll just do 2 rectangles with LRAM. So here you go. I'm doing LRAM. And I'm going to split it down the middle. And split it down the middle. I'm just putting 2 rectangles. Notice that LRAM will give you a what? Underestimate. See? Underestimate. From the real value. Cool or not cool? All right, let's go to the next one. Strictly increasing, and now we're doing RRAM. So here's my scale, A to B, and another scale, A to B. I'm just going to do concave up, concave down so you guys can see. I'm doing what again? Strictly increasing? Yeah, strictly increasing, strictly increasing. And I'm just going to do 2 rectangles. I'm doing RRAM now. Oh, dang. What are you talking about? This will be a what? Overestimate. You can just highlight overestimate or underline overestimate. All right, let's see. What am I doing now? Decreasing? Strictly decreasing. So here we go. Decreasing. I'm going to do decreasing concave up. A, B. And I'm going to do decreasing concave down. Decreasing concave down. And I'm doing LRAM. LRAM. And LRAM. Oh. What do you notice? Overestimate? And now decreasing in RRAM. Okay, now I got plenty of space here. A, B, decreasing concave up, and decreasing concave down. I don't like it. That's fine. And I'm doing RM. And RM. What do you notice? Underestimate from the real area. How do we feel, guys? Do we feel okay? Yeah, nothing crazy. Nothing crazy. All right. This is a real question from a real AP exam. I wrote the notes here of where I got it from. So let me see what year it was. It was year, I'll get it to you real quick, guys. 2006 Form B. Form B. Question 6. So no calculator. I think I might have deleted one of the sections, A, B, C. Let's see if we can do this. Let's see. I don't know. We'll find out right now. You guys ready? We're going to go slow. So we have a table, and it says, let's see, seconds, feet per second squared. So we have a table with velocity and acceleration. All right, maybe we're ready, maybe we're not. We're going to figure it out right now. A car travels on a straight track during the time interval between 0 and 60 seconds. The car's velocity, v, measured in feet per second, and acceleration, a, measured in feet per second, are continuous functions. The table above shows selected values of these functions. All right, letter A. Using appropriate units, explain the meaning of the absolute value of v of t dt between 30 and 60 in terms of the car's motion. Approximate absolute value of v of t dt between 30 and 60 using a trapezoidal approximation with 3 subintervals determined by the table. Okay, 3 subintervals between 30 and 60. So look, you're looking between here, and they told us that we need 3 trapezoids. So here's my first trapezoid between 30 and 35. Here's my second trapezoid between 35 and 50. And here's my third trapezoid between 50 and 60. Are we okay? Okay. Notice, so let's first just do this part, and then we'll talk about what it means in terms of the motion in a little bit. We're gonna go slow, real slow. So notice they have absolute value. So this, I'm gonna put an absolute value on that. You know what? Put absolute value on everything between 30 and 60 for now. Nothing crazy. I haven't done anything crazy yet, guys. Here's my first trapezoid. I'm gonna color code it again. You guys ready? What's my first base? 14. So I'm gonna put 14. Remember, we're doing absolute value. Plus, what's my second base? 10. And I'm gonna multiply that by the height of that trapezoid, and it's gonna be 5. And all this is divided by 2. Plus, let's do my second trapezoid. I'm gonna go to my purple here. What's my first base of the second trapezoid? 10 plus 0 times 15. Good job. You didn't get tricked. All that divided by 2. Plus, what's that third trapezoid? 0 plus 10 times 10 divided by 2. Okay. Cool? All right. I think we're strong and brave, so let's see if we can do this. 14. Here's what I would do. I see that 5. I'm not even going to worry about it. I'm going to go 14 plus 10, which is 24. 24 divided by 2 is 12, and 12 times 5? I can do that. Plus, and then I see a 15 again, so I'm not going to worry about that 15 until the end. 10 divided by 2 is 5, and 15 times 5? 15, 30, 60, 75. Plus, and then I'm probably going to do this first. I guess it doesn't matter. 10 divided by 2 is 5, and 10 times 5? 50. Let's see if we can add this up. I would probably do this one. Oh, it doesn't matter. 60 and 75. Well, 60 and 60 is 120, so that's 135. And then 135 and 50, 35, 45, 55, 65, 75, 85. 185. And I need units. All right. Relax. Well, no. This, remember, we're looking at area under the curve. This velocity is in feet per second, and dt, the change in time, is in, so feet per second times seconds is, nope. just feet.
Yeah.
All right, relax.
Because it's feet over second.
Yeah, look, do a little, yeah, hold on, guys. Do a little graph here. Call it, if you want, it doesn't have to be perfect. 30, 30, 14, 35, 10, then you're at 0, then 60, 10. And then look, just connect it. And then let's think. This is in seconds. This is in feet per seconds. Do you guys see my little graph that I did there? It's not perfect. So think about it. Feet per second. All right, guys, focus, because it is important. Feet per second times seconds. What unit is that? Feet per second times second. What unit is that? Tell me, guys. Feet. The seconds cancel out. Do you guys see that? Let the units help you out, guys. You guys all have taken physics already. Dimensional analysis. Feet per second times seconds is just feet. It's just patas. Yeah. Sorry. Cool or not cool? Yeah, I know. I don't even like my own patas. So, all right. Now let's talk about what it means. So I have 185 feet. What does it mean in the context of this problem between 30 and 60? Yeah, it's what? Give me a specific word that you use in physics. Distance traveled. Distance traveled. So I'm going to write the distance, what do they call it? Car? The car traveled between t equals 30 and t equals 60 seconds is 185 feet. That's what it means in the context of this problem, guys. You guys are the future engineers, and that's what you're going to be writing. The distance the car traveled between t equals 30 and t equals 60 seconds. You got to put this in here, guys, because if you just say the distance the car traveled is 185, you need to be specific. Well, when did it travel 185? Between t equals 30 and t equals 60 seconds. Cool or not cool? Cool. All right. Let's see if we can figure this one out. Using appropriate units, explain the meaning of the area under the curve of A of t dt between 0 and 30 in terms of the car's motion. Find the exact value of A of t dt. Oh, man, we don't know the fundamental theorem of calculus yet. FTC. Yeah, skip. Well, we might be able to figure it out, but because you guys already know that means antiderivative. But I don't want to talk about it yet. So skip it for now. Yeah, skip it for now. We don't know letter B yet. Not yet. Notice they don't, in case you're wondering, Chav, I thought we were finding area under the curve. Notice they don't give us any instructions about area under the curve. It says find the exact value. So, yeah, we'll come back to it when we know it. Dang. Sorry, I was tired when I typed this out. If not, I would have deleted that. Letter C. Between 0 and 60, and this one we do know. Must there be a time when v of t is negative 5? Justify your answer. I don't know, guys. You tell me. Yes, why? What's in the graph? You got to tell me more than just yes. You got to give me a reason. Perfect. And its velocity is continuous, right? You must, look, I'll draw a little graph for you just in case. It doesn't have to be perfect. Look, velocity at 30 is negative 10. So I'm gonna call this V, and I'm gonna call this T. At 30, I'm at negative 10. I'm gonna say this negative 10. And then velocity at 50 is 0. I'm gonna call this 50. And 0, I have a point there. Guys, negative 5 is right smack right here in the middle of this. Remember, velocity is continuous. There is no way to go from negative 10 to 0 without hitting negative 5. Yeah, but they told me that I'm continuous, right? What theorem is that? Yeah, it's one of those. Which one?
IVT.
IVT. Look at the name. Intermediate value theorem. You actually want to spell it out. Don't say, you can say IVT. You don't even need to mention IVT to get the full credit. So what would you do? Let's say you don't want to mention it. If you don't want to mention it, here's what I would do. I would have said, since velocity is continuous, comma, and since v of 30 equals -10 and v of 50 equals 0, comma, there exists v of t equals -5 somewhere where t is between 30 and 50. Period. Full credit. Let me see if that makes sense to you. Since velocity is continuous, and since v of 30 is -10 and v of 50 is 0, there exists v of t equals -5 somewhere between 30 and 50 for t. Does that make sense? You could have also said by intermediate value theorem. So what's another way you could have said this? You could have also, here's number 2. Another way. You could have said by intermediate value theorem, comma, make sure that you state that velocity is continuous, right? Velocity is continuous. Velocity is continuous. You still got to say that. And then comma, by intermediate value theorem, comma, there exists v of t equals -5 since v of 30 equals -10 and v of 50 equals 0. Done. That would have been full credit also. I kind of like the first one better though. Velocity is continuous, comma, by intermediate value theorem, there exists v of t is -5 since v of 30 is -10 and v of 50 is 0. Full credit. Is this making sense, guys? Yeah, we're almost done, guys. We're almost done. Look at you guys go with these AP questions. All right. These are the last two. We got, or the last three. These are coming from UH. So let's give credit to them. From UH. From UH. From Delta. From Delta. From Delta.
Oh, yeah.
Yeah. Yeah. Of course, of course. Select the values of f(x) are shown in the table. What is the midpoint Raymond sum approximation for this using 4 subintervals in the... So now we're doing review. Relax. We're just doing rectangles. How many rectangles do they want me to use? 4. Between 4 and 20. So here we go. Here's the first one, between 4 and 8. Here's the second one, between 8 and 12. Here's the third one, between 12 and 16. Here's my fourth one, between 16 and 20. Does everyone know how I got that? Okay. My delta x, the width of each rectangle is 4. Does everyone know how I got that? Yeah, they're all 4, it looks like. Yep, they're all 4. So here we go. All I'm doing is width times height. Width times height. It's a rectangle, guys. So here it is, width times height. They want me to use which one? Midpoint. So what am I going to use at 4, at 6, or at 8? At 6. What's the value I'm going to use? The 20. It's width times height. The height is 20. So 20 times 4 plus, what's the next one I'm going to use? 37. So 37, and I'm going to multiply that by what? 4. Good job. Not 10. Be careful. By 4. The difference between 12 and 8. There's the delta x's. Plus, what's the next one? 42.5 times 4 plus, what's the next one? 37 times 4. Usually, if you have something like this, it's probably going to come out in the calculator section. If the numbers are nice, then, no calculator. But this one, I feel like you're probably going to use a calculator. So use a calculator. Tell me what that number is. And that's it. How do we feel? All right, let's do some more practice. I'm doing the same thing, Let's see. This time they're not the same delta x. Chav, how do you know? 0 to 1, 1 to 2, those look the same. But look, 2 to 5, 5 to 9, 9 to 11. I guess I didn't even read the question. Let's read the question first. Write Raymond sum, approximation between 0 and 11. How many rectangles do they want me to use? 5, as indicated by the table. So notice our delta x's are not the same now. Here's my first rectangle. Here's my second. Here's my third. Here's my fourth. Here's my fifth. I'm linking them to what I'm going to be using. All right. What's the width of my first rectangle? 1. And they want me to use right Raymond sum. So what number am I going to use? 11 or the 9? The 9, because it's the rightmost value on the curve. Does that make sense? Plus, between 1 and 2, what is that width? 1. And what value am I using? 5, because it's the rightmost value. What's the width between 2 and 5? 3. And what value am I using? 15. Plus, what's the delta x between 5 and 9? 4. And what value am I using? And then between 9 and 11? 3. And what value am I using? Wait, is it 3? 9, 10, 11. 2. It's all good. It's all good. And we just got to be careful though, because we would have gotten the point for the Raymond sum, but we would have lost the answer point. Everything looks good to me. 193. Oh, you're fast. Bless you, miss. 193. Are we coming down with the sickness? No.
I believe these questions are on the third section.
All right. Let's go to this last one here. Let f be the function defined by that, 2ln x. If 3 subintervals of equal length, so they're equal length now, are used, what is the value of the right Raymond sum? Okay, does everyone know how 2ln x looks like? Do you want me to draw it? Are you guys visual? Okay, here's how it looks like. Come on, you don't have to be perfect, guys, but we should at least know like some basic graphs. Here it is, 2ln x. It crosses the x-axis at 1. That's why they have a 1 right there. Probably. Put a 7 here. And how many rectangles do they want? 3. So let's see the difference. Okay, here it is. Delta x is 7 minus 1 divided by 3. So 6 divided by 3, which is 2. Okay. That's all good. Let's leave the bird alone. It's just being a bird. All right. Right Raymond sum. Here's my first rectangle. Here's your second rectangle. Here's my third rectangle. Here we go. So all I'm doing is length times width, length times width. I'm just finding area of a rectangle. First rectangle. So this gap, let's see, what did we say that gap was? So 2 times, and I'm doing a right Raymond sum. Oh, you definitely need a calculator because it's 2ln x. So 2 ln of 3, close it. That's the first rectangle. Plus 2, parenthesis, 2 ln of 5, close it. Plus 2 times 2 ln of 7, close it. You definitely need a calculator for that. Give me as many digits as it goes. 18.6158. Did you guys get that?
I was literally sitting there not having money.
Yeah. Try it out, guys. Try it out. Come on, Espinosa, try it out.